there.
Just settling in. Now that something's gone wrong, I feel better.
We'll double it. Thank you. We're live. Hello, everyone, hybrid. We've already done this before, but we'll go over it again. Welcome to the first in-person audio programmer meetup since 2020. My name is Harriet. I'm one of your co-hosts for the evening. I'm an audio engineering student. I co-host Dynamic Cast here with Rachel. That's why I'm here. And Josh was kind enough to bring me down to sort of lead things around and stuff. So I would like to thank our sponsors. Let's see if I've memorized it. It's Sonox, Juice, and Focusrite. So we give our thanks to them for providing us with the support we need to run these events, both hybrid and in person, and it's been absolutely fantastic. So Timo would like to say some things before introducing Rachel.
Yeah, hi. Is this working? Hi, my name is Timur. I'm also one of the co-hosts tonight. I work at JetBrains. We make, among other things, the C-Line IDE, and I have a bunch of free C-Line t-shirts in various sizes. So if you want to have one of those free t-shirts, please come and find me later. The other thing I wanted to say is that it's so great to be back here in person. So we had one of these in March 2020 back at the Strong Room studio, and that was the beginning of this meetup, and it was great. And then we had to go online, which is not necessarily a bad thing, but it's still very, very good to finally be back in person. So that's awesome. So when we were online, I was co-hosting for a while. Then I actually, Rachel, who's here with us tonight, actually took over from me as co-host. So it's my great honor to introduce Rachel, who's going to be doing the first talk of the evening. Rachel just recently finished her degree in digital audio engineering at the University of West London and started working as a C++ software engineer. And today she's going to continue her series on DSP introduction talks. And that's number 2 in the series, right?
Yeah,
so
last month we did.
That's very exciting. So please give a warm welcome to Rachel.
Thank you. Thanks, Timo. Hey, everyone. This is my first in-person talk for the audio program meets. And this is, like Timo said, the second episode. You'll have to excuse me. I'm not so used to public speaking, and I'm recovering from an illness. So if I need to take a drink or clear my throat at any time, please bear with me. So today we're going to be talking about common signals and transformations. The objective of this is just to look at some common signals, their notation, familiarize ourselves with some common operations on signals as well. And yeah, just get some understanding of some fundamental DSP concepts. So the first thing I'll mention is that all the signals and operations we'll be looking at today are discrete time or digital. I may occasionally make reference to continuous time counterparts, but I'll do my best to make the distinction if that happens. If you're familiar with DSP notation, or you tuned into last month's DSP corner, you'll recognize that I'm using square brackets and the independent variable n throughout the presentation, denoting discrete time signals and systems. The first and potentially the most significant signal I'm going to speak about today is the unit impulse signal. This is sometimes referred to as the impulse signal or the Dirac delta, though the latter is usually reserved for the continuous time counterpart. The words signal and function are generally used interchangeably, so you can assume I mean the same thing whenever those terms are used. How is it that such a seemingly simplistic signal, such as the unit impulse, could be so significant? Understanding the power of the unit impulse and how any digital signal can be expressed as a sum of weighted, shifted impulses is the key to understanding essential DSP concepts such as linear time invariance and convolution. First, let's define the unit impulse signal. We introduced this notation briefly in last month's episode. On the left of the equality is the notation for unit impulse signal. We use the Greek letter delta here to express that this is a unit impulse signal. On the right-hand side of the equality, the signal is defined for every integer n. We can see that the unit impulse signal is a signal that has a value of 0 everywhere, aside from n equals 0, where it has a value of 1. Impulse decomposition is the first step in understanding the fundamental DSP concept of superposition, which we will work up to and gain a basic understanding of today. Say we have an arbitrary signal x of n in the top corner here. We can decompose it into a sum of weighted shifted impulses. But before we do that, it's worth mentioning that x of n is an odd signal. And by that, I do not mean that it is peculiar. I mean that it has odd symmetry about the y-axis. This axis highlighted in red here. The conditions for oddness are as follows. X of minus n equal to minus x of n. This way we can check the above signal for oddness. I'll come round in front. So what we have to do when we check conditions like this is just plug in a number for n. So let's say we plug in 1. We've got x of minus 1, which is this line here, which has a value of minus 4. So this should be equal to minus x of n. When we bring the minus sign out in front of the signal here, that means that we are timesing the amplitude by minus 1. So we've got a value of 4 here. 4 times minus 1 is also minus 4. And we can say that this signal is odd. As you can see, all the other signals in both directions are the same. We can also check the conditions for evenness. These are x of minus n is equal to x of n. For this signal to be even, all of these impulses on this side would have to be made positive, and then we would have an even signal. There are 2 very important signals in DSP that have these conditions. The first one is a sine wave. A sine wave, by definition, is an odd signal. You can see that it has oddness around the y-axis. An important even signal is a cosine wave. We can see that it has evenness around the y-axis. Okay, let's get back to impulse decomposition. So we're going to decompose this signal, x of n, into its individual weighted shifted impulses. So the signals you'll see here are 0 for most values, but each of them has an impulse component of x of n. I've highlighted them in separate colors so it's clear which ones belong to which. So you can see that x of minus 4 has this value of 1, and we've decomposed this into x of 0 n. Then we have a value of 2 at minus 3, which is this one from our original signal. A value of 3 at minus 2, which is this one from our original signal. And I'm sure you can see what's coming next. We've got the next one. And finally, I've highlighted 0 as well. I couldn't decompose the whole thing because I ran out of space, but hopefully you get the idea of how we're splitting this signal up and how, if we summed these signals below our x of n together, how they would form this left-hand side of our original signal. For this reason, all of our decomposed signals need to have the same length n as our original signal, so that when it comes to adding them back together, we can add all the points point by point to obtain the original signal. Oh, is that where I'm going? Yep. Cool. So, last month I spoke a bit about introduction to systems, and I showed this block diagram, which is generally how a system is shown in most textbooks for DSP. you've got some input, a box which represents the system itself, and some output y of n. Last time that I showed this system, I put a capital H on it, and I said that I would explain why in a later episode. This time we've got h of n, and that is because that is the notation for the impulse response of a system. And the impulse response is simply the output of a system when an impulse is used as the input. So I want to define linear time invariant systems. Last time, at the end of the talk, I spoke about the conditions for linearity. This is, a system has to be homogeneous and it has to be additive. Homogeneous meaning that if we scale the input by some factor, then the output is scaled by an identical factor. And additivity meaning that if we add two signals together in the input, then those two signals pass through the system without being interfered with. So those are the conditions for a linear system. For a time invariant system, we can add some shift to the input signal and preserve the shift in the output signal. All of these conditions are about preserving something, whether that's a scaling factor, an addition, or a shift. Why is it useful to be able to express a signal as its weighted, shifted impulses? Last episode, we introduced the idea of systems. One way we can input signals into systems to give this idea of, one second. Oh, sorry. I'm getting used to these controls. So this image is taken from the book, The Scientist and Engineer's Guide to Digital Signal Processing. This book was recommended to me by Fabian Wren-Giles, someone you might know. It's a very good book. And I chose this particular picture because it visually describes quite well how you would decompose a signal into its impulse components, feed them through a system, each time gaining the impulse response for each additive component, and then using synthesis, or plainly adding, add them together to receive an overall output signal. And the whole idea of this theory is that when you feed the individual impulses through the system and add the impulse responses, you receive the same output as you would if you fed x of n through the system without decomposition. And I've notated here what it looks like when we have a weighted shifted impulse. And these are expressed in terms of our original impulse, which we saw was 0 everywhere and had a value of 1 at the origin. So we can see here that we have a minus sign out in front. That's because our signal has a value of -1. And it has a shift of 4, because it's shifted 4 places from the origin, where the original impulse would usually be. We have this one, which has a scaling factor of -2, because this impulse has the value of -2, and a shift of +3. We have a scaling factor of -3 here for this impulse, and a shifting factor of 2. It might seem a bit counterintuitive that we add to shift to the left, but this is what you can think of as an advancement if we're moving this way, and a delay if we're moving this way. Another common signal you'll come across is the unit step signal. This is a function that resembles a step, with a value of 0 everywhere until point 0, n equals 0, where it suddenly steps up to 1 and has the value 1 for all n after that. This is what we call a causal signal, meaning that it has non-zero values after the origin and 0 values for all n before the origin. For that reason, if you wanted to make any signal causal, you could multiply it with the unit step function in order to receive a causal version of your other signal. Let's talk about real exponential signals. An exponential function is an exponentially increasing or decreasing time series. Real exponential signals refer to an exponential signal where both the base and the exponent are real numbers. We want to look at real exponential signals because we'll later get into looking at complex exponential signals, which are a fundamental building block of DSP. And I wanted to show you what the real exponential signals look like for different values of alpha. So if we ignore the scaling factor capital A in front just for a moment and look at what the effect of alpha is on each real exponential, we can see that when the mod of alpha is larger than 1 and alpha is positive, we get an increasing exponential. This is for a value of 1.2. We can also see that when the mod of alpha is larger than 1 and for a negative value, such as minus 1.2, we have this oscillating, increasing exponential. When the value of alpha is smaller than 1 and alpha is positive, we have this decaying exponential. And when the value of alpha is smaller than 1 and is negative, we have this oscillating exponential, but in the other direction. Next, we're going to look at some basic signal operations. First, we're going to look at time shifting. This is nothing but adding a shift in a positive or negative direction to a signal. We can shift a signal to the left or to the right. When we shift the signal to the left, it is a negative shift, but it is called advancement of the signal. And when we shift the signal, oh, they're the same. Plus is going to be to the left, and that's an advancement. Minus is going to be to the right, and that's a delay. I'm just going to have a drink before we shift the signal. So this is an example of advancing a signal. We can see here that I've added a shift of +2, which means we're going to have a shift to the left. If you're experienced with this, you can do it just by visually seeing, like, okay, this used to be 1, now -1, now it's going to be -3. But one thing we can do is plug in the values for n. So for this signal, we want the output x of n plus 2. Say we want to find the output at point 0. We're just going to plug in 0 in the place of n. 0 plus 2 gives us x of 2. So we're going to take the signal at x of 2 and place it down here at 0. Then we want to find for n equals -1 in our output signal, plug it in here, -1 plus 2, +1. So we go and grab x at +1, bring it down here. Same again, want to find y at -2, plug in, I'm sorry, I just realized that, oh no, you have a screen there. I thought I was standing in the way of everyone there. All good, all good. Okay, y -2, plug that in, -2 plus 2, x of 0. And you can see that that comes down here. So we've shifted the signal to the left 2 spaces. Nice and easy. Oh, forgot about my highlighted ones. Now I've got my laser pen. Okay. This is another example. This time it's just to the right instead. So we have our output signal y of n, x of n minus 2, and y of 0. Let's calculate that. Just plug in 0 minus 2, get x of minus 2. So we're going to take that, bring it down here to 0. You can see what's going to happen next. All of the other values are going to follow, and we shift it 2 places, causing a 2-sample delay. The next operation is time reversal. We can see that this is an example, another example of an odd signal. In time reversal, the notation is x of minus n. So we want y of n, the output, to be x of minus n. And what this minus n does is it means that we are going to flip the signal around the y-axis. So simply all we do here is just whatever value we have at x of n, for the output we make it negative, and vice versa. So you can see here that this is a version of this just flipped around the y-axis. There we go. Final operation is time scaling. Time scaling is denoted by a scaling factor a that goes inside the brackets next to n. So we're multiplying n by some scaling factor. What we need to know here is that when a is larger than 1, we have a compression, and when a is smaller than 1, we have an expansion. This is another one of those things in signal processing which is a bit counterintuitive, like with the shift, when you think it would be positive going forward and negative going back. But yeah, it's just one of those things, and we'll see what I mean next. So this one is going to be a compression. We also call this downsampling, and that is a condition when the a is larger than 1. So here the example is y of n should be x2n. So whichever n we have, we're timesing by 2. So if we come down here, we want to find y of 0. 2 times 0 is 0. So with time scaling, if we have a value at the origin, that will always stay the same, because anything times 0 is going to be 0. The next one, y of 1, we want to find, we plug in 2 times 1, as it's 2 times n, and then we get x of 2. So x of 2 comes down here. The thing I will say about time scaling is that, unlike time scaling in continuous time, we actually lose information here. As you can see, we've got 5 samples in our input signal, and down here in the output, we're actually just left with 3 samples. That's because, say we try and calculate y of 2, plug in x 2 times 2, then we're given x of 4. Now, n equals 4 in our original signal is 0, so we actually have nothing there that we can bring down here to put at y equals 2. And the same for minus 2, so we're left just with this compressed version of our original signal. So the opposite is expansion, and also referred to as upsampling. This time we have an a which has a value less than 1. You can express it like this, but you can also express it like 0.5 times n. You'll see both in DSP textbooks. Let's have a go at upsampling this signal. So we want to find y of 0, plug in 0 divided by 2, 0. Like I said, 0 is generally preserved when we're talking about time scaling or when we're talking about reversal. What about y of 1? So if we plug in y of 1, we've got a calculation for n where 1 over 2. So that's going to give us 0.5. So with discrete signals, we don't actually have 0.5 as a value of n. We can only represent integer samples. So this is something we can't do. So this one will just be left as 0. Y of 2, 2 divided by 2, x of 1. So our value that we had for x of 1 is being expanded over here. And you can see how this is causing an overall expansion of the signal. Our signal started off at -2 to 2 for non-zero values and ended up with values for -4 to 4 for non-zero parts. We can see also that for 3, we do 3 over 2. What's going to happen? We don't have an integer value, so we cannot do that. So y of 3 is also 0. And then for 4, we can see that we shift this one that used to be 2 way out here to 4. So we can say that for any odd n, we can't have a value when we're doing upsampling. What we can do is we can use interpolation to fill in these missing signals or missing gaps. Yeah, I think that describes upsampling. And yeah, that's my final slide. Thanks for rattling through that with me.
Right. Thank you, Rachel. I think you said you prefer not to answer questions during the talk, right? But you'll be around, right?
Because it's just because it's every month. So
okay.
But people can always ask me questions on the Discord or Twitter. My handle is Madam Modular.
All right.
Or on LinkedIn.
Amazing. Thank you so much.
Thank you. Shall I take this?
Yes. So we're almost ready for the break. I just have one little thingy which I wanted to show. I have like exactly one slide. This will hopefully work. Let's see. Does this work? Yes. So at JetBrains, we don't just give away free t-shirts, but we also give away free licenses. So you can get a free 1-year license for any of our C++ related products like C-Line, AppCode, ReSharper, or Writer. If you want to get a free license for any of those things, you can actually choose which one you want. All you need to do is you need to think about your favorite code snippet in any programming language. And you need to send that to me. So either if you're here in person, you can just find me during the break, or if you're online, obviously you want to include everybody who's online, you can send me an email. This is my email address. If you send me your favorite code snippet in any programming language by the end of this meetup, then you might be able to grab one of 5 free licenses that I can give away today for C-Line or any of the other C++ related products. Okay. With that said, we're ready for the break. So, Josh, when are we going to reassemble here? Is it going to be in a half hour? In half an hour. So we're going to be back here at 7:30 with the second talk. And until then, enjoy the break.
The camera's alive. The camera's just like staring at me right now. Shall I start doing like finger guns? Did the camera stay live during the break? Shall I just start doing finger guns of it?
See what happens. See what happens.
Yeah, just make it more interesting. Looking a bit awkward. Are we all ready? Yeah. Love this. Josh, how are we doing? Are we good to go? Yeah? Keep talking. We're good. Okay, I've been given the thumbs up. So welcome back, everyone. Hope you had a great break, got a drink or something. I'd like to give my thanks to Rachel for that great DSP talk. Give her a round of applause, guys, please. Yeah, thank you. So now that you're all fully wide awake from that DSP talk, we're going to bring it back a bit. And I've got the pleasure of introducing Ricardo to you guys. So come on, Ricardo, come in.
Hi.
This is Ricardo, everyone. And he is here today to talk about his latest project in building a music education app called Midi Circuit. So take it away, Ricardo.
Yeah. Hi, everyone. Good afternoon, good evening. So I'm going to talk about Midi Circuit, this app that I set myself to build. Now we're like little team as well. So what is Midi Circuit? Midi Circuit is an interactive learning experience that is designed for everyone, that combines both educational and music-making content into one friendly package. At least that's the goal. But first, let's talk about the problem. I've always been frustrated by how difficult it can be to learn complicated MIDI instruments like synthesizers, drum samplers, samplers and drum machines. The included manuals don't teach you how to make music. They don't teach you important concepts you need to know, or even how to make beats. So we invented Midi Circuit, which teaches beginners how to use complex instruments and helps them get started making music right away. So let's get started. Okay, this is a snippet of what Midi Circuit is. You can interact with our lessons, and you can play around and learn new concepts right away when you buy your synthesizer. I'm going to show you what Midi Circuit looks like. This is our latest staging build. Hopefully not too broken. Okay, great. Unable to load the build. That's already a great start. That is already a great start. Okay. Yeah, this is not good at all. Hold on. I think we're gonna still get there. Can you? Okay. I'm really sorry about that. This is the worst moment ever. Okay, I think we'll able to do this. Is there any way I can move? Yeah, like how I can. Okay. Okay, let's maybe. Do this. Hey. Okay, so this is not the app. I have to literally use our beta flow sort of like Figma designs to improvise this. So when you get started, on the left-hand side, you have context about the lesson you're about to perform and instructions. And we try to keep everything in the middle interactive. And what you see would then communicate with your instrument and highlight the pads. And once you interact with the instrument or with the UI or with your finger using an iPad, or macOS with your mouse. So we use all of these interaction points to give you an immersive experience, and so you get options and you don't feel limited. In this particular lesson, you just go and play around with the sounds. If I did have here, I do have my push there, but the idea is that you can also go and make a beat. If you're someone more proficient, you can just like live drum. And this is just our onboarding. Then we build up on the concept of sounds, and we introduce patterns. Then we build up a little bit further on it. We introduce tempo, so now you understand like rhythm as well. You can go from house to hip hop and techno and whatever you want. So this is, the goal of this journey was just to introduce you to the mechanics of Midi circuit. Then you can go and create your account. And you would land on the home screen, and you can see you already completed your first circuit. You can then add it to favorites, and then you can find more circuits to complete. As you can see, it's very much like targeting Ableton. It's just because it was we kept our beta phase focus on a product that we knew well and was complex enough as well to create our API, so we can then transpose that that knowledge into other devices like Novation, Launchpad, which we're integrating with at the moment. This is another type of circuit. It's a circuit that you would be able to go through the instrument, and the instrument, this is all native, and you'd be able to communicate with your physical instrument. If you don't have the instrument, it's all good. You can still click around and learn a little bit about this. So this is pretty cool for teachers, where they can explain concepts, or kids can take away home and play with it, even if they don't have the instrument. But if they do have it, it's a more engaging experience. Okay. Boom. We're back in, and on your profile, you can track your achievements, your streaks, and do all the profile basic stuff. And here it's just basic settings. So I guess let's go back to the presentation. Okay. So what Midi Circuit tries to achieve is help you master your instrument, learn music production workflows. We try to break down in simple concepts step by step, so you feel like you're progressing and learning concepts that you can then take and build on your own on a DAW, Ableton, Cubase, or any other place. Music theory, so you can play better. I've always seen people struggling, like how to learn how they can play, for example, a major scale on the Ableton Push or the Launchpad or other instruments. We also want to be able to do sound theory, for example, like synthesis. And we want to do all this stuff with deep integration, so it feels connected and engaging, so you love your instrument the same way a guitar player loves their guitar. I'm a bass player, and I love my bass. I literally want to sleep with my bass. So maybe one day you want to sleep with your MIDI instrument too. And we want to do this all in one place on Midi Circuit. So let's talk about the tech, since we are here at the Audio Programmer Meetup. You're all techie. So the tech behind it is quite simple. There's always like some bits around and some other ideas that we try that are left over, or maybe we'll pull back later. But on the front end, we use Swift and Swift UI for the app, and everything that's audio and MIDI at the moment is handled by AudioKit. On the back end, we use Go and GraphQL for our APIs. And the content itself, the media, all the strings, all the translations and things like that, they live in Prismic, and they just like piped into our Go API. It behaves like a microservice, and then we consume that in the app. Yeah, that's it. And now I'm gonna give a little bit more context around the journey to get to here, to what you've just seen. I was actually at Ace Hotel. I had the idea for a while, and I was thinking about it, but I was at Ace Hotel, which now is closed, but it used to be sort of a creative hub around here in Shoreditch. And when I was sitting there, I always felt really inspired. And sometimes I would just hang around the city, in Shoreditch in particular, and I would work a little bit, and then I would go exploring, take pictures. And this day I was there, and I was like, I already had coded some prototype stuff just to get an idea of what we could do with particularly with Ableton Push. And I was like, okay, I'm going to create a landing page this time and validate if people are actually really interested in this. I created this landing page in 2 hours or so, and then I posted on Facebook groups, on Reddit, and within roughly 24 hours, 400 people signed up. So I was like, okay, that's pretty good. Like, there was almost no marketing, no money put into this, and 400 people are interested. So I was like, let's start building this. But to be honest, only 2 years later, maybe even more, because I was managing teams and I was focused on my career, and I was just always trying to find the right time to give love to this and all the research I was doing as well on it. Only around the pandemic in November, I decided to take the plunge and invest my savings into this project. So I hired my good friend Delcio Batista, who's a UX UI designer, and he started working on the wireframes, and we started interviewing people that were in our early access user base. Some of them were music tutors. We were approached by incredible people, different people from everywhere, and we were like, well, let's talk to them and learn from them and try to build something that is, that they're gonna love. Then around April 2021, we built our first prototype. This time I had dropped the contracts that I was doing, and I focused on building an MVP a little with Swift and Swift UI, basically replicating the whole design. After a couple months, I go back again, like sort of part-time, because money is running out. I was paying my rent here in London, all those things. And I'm kind of like, I'm not risk averse, but I can see like where things are going. So I go back into that, but we keep progressing. I applied to Apple Entrepreneur Camp, and then Apple chooses us to be a part of the Entrepreneur Camp, 8 people, and it was an amazing experience. We learned so much through the 2 weeks there, and we then do a demo to the Apple employees, and we get time to ask them questions as well, and get their help on a little bit on the code as well. So after the validation we got from like leaders at Apple, people that, for example, work with multiple music apps and work within the music platform itself, we felt validated, and we were like, and I said we need to accelerate this. So I then went and hired an iOS and macOS engineer to support me, because things were really slow, and some parts, to be honest, I wasn't as expert as she is. I'll show you Dory soon. And yeah, then we started focusing, building a roadmap, focusing on getting to our beta and communicating more what we were up to, and even within us, the little group we have, the team, just be more accountable and trying to deliver the things we promised to deliver. And our goal is to release a first version to the App Store around midsummer. And yeah, so what's next? So next is, I think we're going to focus on securing our seed funding round, so we can spend time working full-time on this and giving the love it needs and building an awesome product, a magical experience. We want to add more content before we launch on the App Store. Then we launch on the App Store, and then we're going to start working on our creators program. We already were approached by multiple music experts, want to work with artists and schools and try to create like rich content experiences that will help people learn their electronic music instruments. So to do all of this, we need a great team. And here we are. I'm Ricardo, the founder. The other Ricardo, which not is over there. The other Ricardo, my co-founder, and Delcio, the product designer. Dorota Piachekova, our iOS, macOS engineer, who makes all the UI look nice and pretty. And our senior software engineer on the backend in cloud, Madhuri Kadam. And yeah, here are contacts. You can find us, you can email us at team@yonko.level, which is actually the company that I built to kind of like fund this whole thing. Our website is midicircuit.com, and you can reach out on Twitter at midicircuit, or you can reach out directly to me. It's _TexBrown, TX Brown. And that's it, really. So thank you for listening to me. Do you have questions? I think there was supposed to, but like maybe one or two.
Yeah.
Yeah.
I can make my mic live. Yeah. Do you want to?
Yeah, just wanted to ask, what's your target audience, like target user base?
Yeah, so the target user base, I wouldn't say everyone, but it's really people who either just, right now, it's people who just bought a MIDI instrument or they lent it from a friend, and schools. That's kind of like the audience we're looking for. We already seen schools are adopting electronic music instruments into their classroom. In Europe, it's becoming mandatory to have at least 1 hour per week of music. And schools across US and Europe are adopting electronic music instruments and all this cool stuff that some people here build. And we can see teachers struggling to hold like some stuff like this to explain them. But if we build like some virtual versions of those instruments, that they can use them to do their job better or more easily.
Any more questions? Yeah.
Thanks. I just wanted to ask about focusing on macOS, like whether you had plans to sort of port this over to Windows at some point, and how you kind of decided, like, I guess you got to sort of wonder, like, I guess there's more people using Windows, but maybe more of the people using Mac are doing music or something.
Yeah. So typically, in this industry, people would use Juice. I spent a lot of time talking with Josh, making these decisions actually, and I'm not a fan of Juice. I'm sorry. I have a background in engineering, but I also have a strong background in UI engineering, and I just didn't want. I really like to create experiences that feel native, and I didn't feel like I could do that without spending a lot of time learning Juice on its own. Maybe it's possible, or trying to replicate the native experience. I think it would be too hard. So what I thought, and after I talked with a bunch of people, and then I was like, you know what? If there is money, there is a way. So if we do make enough money, if this thing makes sense, if someone wants to help us build it for Windows, it will happen. And we can have a team, and we'll make it as good as possible on Windows. Another option, perhaps, is using WebAssembly, converting our Swift UI views into native views, translate them to some web version on Windows. But I'm not sure. Again, like all this stuff is kind of like hurts me a little bit. But yeah, we will have to though. We will have to. There was it's a little bit of pressure and other parts of this.
Okay, cool,
Yeah.
cool. Well, big thank to our sponsors,
Alright.
Juice, guys. Don't listen to him. Don't listen to him.
I'm sorry I
Boo.
said that. But I have
Shun the
huge
non-believer.
respect for the project. Like, that's for sure.
Any more questions? We've got one over the back. You guys are getting my steps in today. Thank you. Come over to Hugh first.
Another technology stack question, but why did you pick Go on the back end? I'm just curious.
Yeah, so I think Go is really simple. And I was used to, well, is this? I cannot.
I think you're on.
Here we are. Yeah, so at Lush, I worked at Lush, the cosmetics company, and we were using Go extensively, and I got more and more familiar. I'd built a couple projects with Go already, and Go it's just really easy to learn. That's the reason why we chose Go, and strongly typed. I felt like I wanted something reliable. Yeah, that's really it. And I want something like with high performance.
Are you okay for one more question, Ricardo?
Yeah.
I'll do one more, and then
One
I'll have
more.
to move
Yeah,
on,
cool.
I'm afraid. Sorry.
Yeah, it's really good to see you talk today, because in a way, I have a similar parallel journey, but I'm at that stage. Basically, I'm doing like an AR music app, but I use Unity. And I'm at that stage where I want to kind of build a team. And how did you find the right people, especially at this stage where the money will come maybe a bit later, and people that you can rely on, you know?
Yeah, that's a great question.
And how did you compensate them?
Yeah, exactly. So what I did was I took my expertise and sort of my social capital. I went contracting, and fortunately there's people willing to pay pretty well for my skills. Then I take about 30% for my own personal stuff, 70% I try to dedicate it fully to Midi circuit. And then I find people that are willing. I literally ask like, how much you want? Like, oh, this is my price per hour. And then I interview them. There is no sort of like coding challenge. I'll pay you to work on Midi circuit for 2 weeks, and I'll see how you do. This is literally it. And so far, everybody feels happy. I think everybody is getting a good rate. Some people is a good rate like within their country, I think. So for example, Dory is actually traveling around the world all the time, and she's working part-time. So another thing is that the team right now is literally built on part-time. That I don't know, like even when we get funding, I'm not sure it's gonna be sort of worth the pressure of everyone being full-time on it. Because honestly, I want people to be happy and just get focused, deep work when they, come in to work. So let me just add up something else. One thing I noticed is that, sorry guys, but like women are really honest when they are interviewing, and guys tend to inflate. I think this is common sense though. Inflate so much like what they can do, the time they have available, where women would be like, I have this time available. This is it. This is how much I want to earn. This is how much I'm worth. Like, I want to go for it. And these are my skills. I don't want to do Go. I don't expect me to do this. I want to do this, and just you get that. And like, I'm really happy with Midi Circuit starting with that foundation, and I learned so much. At Lush, I had worked with other women as well. They're all doing great. So shout out to women, and shout out to the other sex. And yeah, that's it's just to prove that there is space for women in engineering, and they do an incredible job. Yeah.
Fantastic. Thank you, Ricardo. Thanks for your time.
So can I wrap this up? Okay.
Hey, I'm back. Thank you so much, Ricardo, for telling us about Midi Circuit.
Thank you for having me.
Really useful tool for musicians and music educators. Okay. Yeah, let's get set up.
Okay. Do we need to swap this?
Oh, thanks for the shout out as well, Ricardo. Pardon?
This is not going to well.
Speaking of women and underrepresented groups in C++, me and Harriet run a group called Dynamic Cast.
Sorry.
Happens. It happens. Is it going to be on the second Monday of every? Second Monday of every month, 7 to 9 p.m. at the Focusrite offices near King's Cross. So please get in contact if you or someone you know is qualifying as an underrepresented group, in your opinion, to get in contact with us.
Can we have one for chess?
Oh yeah, we have. Well, I'm on Twitter. Madam Modular is my handle. What's your handle?
So we also have a Twitter for the group as well. It's dynamic_cast. I know it's
One, two.
great. You will find it. We've got. I'm one of the admins. Yeah, I'm one of the admins. So you'll end up chatting to me probably if you're based in London. I want to identify as that group. So, and you can reach out to me as well. I'm Drury_Harriet. So, yeah, brilliant. Yeah.
We're trying to increase diversity in the C++ industry.
Just wanted to say something really super quick. Some of you may be expecting the Juice 7 preview from Tom Poole, but Tom couldn't unfortunately make it down tonight. So
Well, he's offended now. He's taken umbrage, so he's not coming. He heard what was said about Juice.
oh no,
He's just
I
like
know.
stormed out.
He did
I
storm
saw him
out.
getting back into his limousine.
I had to make something up. So yeah, Tom couldn't make it down. But if you're looking for information about Juice 7, it is on the Juice forum. So it's forum.juice.com. Juice is great for some people. And I'll hand it back to Rachel.
Cool. So next up tonight, we've got the formidable force that is Julian Stora and Cesare Ferrari. And tonight they're going to be talking a bit about what they've been working on lately. They've just recently come out of stealth mode, and they're going to be giving you an introduction to Soundstacks. Take it away.
Thank you very much. It's so nice to be back in a room with people and beer.
Sorry, I think I'll sit down and I'll hop in when.
Okay. So we won't keep you away from the pub too long, because that's why we're all here really. But Josh asked us to come along and just say a few things about what the hell we're doing now, because Ches and I sort of went into a bit of a sabbatical mode for a lot of 2021, and kind of went off the radar. And sorry, is this feeding back? No. You're okay? I'm getting okay. And looked around for new avenues we could pursue, and ended up doing what I'm about to tell you about. We announced this publicly, our existence as Soundstacks Limited, about a month ago. But you're actually being treated as the first public announcement of a bit of what we're actually going to be doing, because so far we just said, hello, we exist. So, you might have heard about these guys, Soundwide. Now, this used to be, you would know them better as the company formerly known as Native Instruments and Isotope, who have, and Plugin Alliance and Brainworks as well, all mashed up into a big audio mega corporation now. And if you see that on the end there, the little Soundstacks is as part of this big group. So what's happened is we got chatting to them, and we said, we're looking for something to do, and we're pretty good at building new audio platforms. What are you guys up to? And they invited us to come and get involved. We're all alongside each other in this picture, but kind of really Soundstacks is a little company on the bottom of this big 700-person Soundwide company. We're a little, so far, 2-person company sticking out the bottom, doing our little thing. When they invited us to get involved, we sort of, okay, come on, what's it all about? And they have a really great mission statement that drew us in. And the kind of the pitch for this new Soundwide organization is all about keeping musicians in the flow. It's like they've got this whole mission statement about, it's about getting rid of the faff and the mess around the fun bit of making music. And we just really like that as a concept, and I think we've really bought into that. So our role within the group, technically, it's this chunk of text here. This is the official. We're in an independent sub-company of the Soundwide group, and we will drive the development of new audio platforms aimed at improving productivity and performance for audio developers across the industry. And that our interpretation of that is we're there to keep, whereas Soundwide's role is to keep musicians in the flow, we want to keep the developers in the flow, audio developers in particular. So that's our goal. And we're going to build stuff to do that. This isn't showing up for some reason. The colors are all wrong. There should be a big yellow bar down the middle there. Well, anyway, this is a good illustration that the Soundwide guys were doing when they were pitching the flow thing. Is like they said, imagine taking 1 hour in music creation. What do you do in that hour? You've got a job. You get 1 hour in the evening. You're going to sit down. You're going to make some music. How much of that do you actually spend making music? And you sort of, you spend your first 20 minutes just installing software or buying software and setting it up and making sure it works again. And eventually you get into actually playing and doing a bit of composing and the fun bit. And then you have the boring, or some people don't find mixing boring, but some people do, and mastering and all that kind of thing at the end. And we sort of, there's my yellow bar. So we thought, let's think about that in audio software. And it's even worse. I mean, You know, you sit down to do a bit of coding, you pull things in, you fix the mistakes, it doesn't work, it's broken. It's like you eventually get down to the fun bit, you write a bit of code, you have a good idea, you get it working, you wait for minutes and minutes and minutes for it to compile, it doesn't work, then eventually you push it to CI, Chez sends me an angry email saying that I've broken something that I didn't test on my machine, and so on. It's like, it's really grim. So what we're going to build is stuff to make this better. So what are we going to build? I mean, this is a really nice opportunity to do something very clean slate. Like, we can do anything we want. We have pretty much a blank check to build something great that Soundwide can use internally, but which will benefit the community and audio developers in general as well, and just be a really great platform for everybody to use. So we're going to go through a bit of a review of the good and bad bits of what we do at the moment, and try and boil it down to what we should be doing and what we shouldn't be doing. Now, what everybody does at the moment, obviously most people who are doing pro audio, we do C++. And C++ is good, it's standard, it's, you know, I've been doing it for countless 35 years or something, I'm still getting the hang of it. It's great because it runs fast, you can do anything. That's why most people adopt it for a pro companies, because you're never going to get to a point where I really need to ship this product tomorrow, and there's a thing I'm trying to do, and all of a sudden I can't do it, and there's no way I can fix the tooling to do this. You can always go down and write a bit of assembly language if you have to. You can always do, like, you can really, there's no brick walls in development, and that's very important when you're actually building a company with schedules around something. The developer tools for it are very, very powerful. They've been around for a long time. They can do, we've actually just come back, I'm looking a bit bleary, we've been at a 2-day LLVM conference where it's like, I mean, it's like the geek level is exhausting. This is like, these are the people who write the compilers, and we're just like, oh gosh.
There were a lot of beards.
There were a lot of beards. There were a lot of, yeah, a lot of.
There were a lot of very smart people.
Very smart people, and who would, you know, a lot of it was way over my head. But these are the people who write the tools, and the tools can do amazing things. And if you're really trying to debug something incredibly complicated, you want C++ tools, but they're very, very hard to use. And you can also deploy C++ everywhere. If you want to run it in the website, in the web, you can compile to WebAssembly. You can M-scripts in it. You can run on weird little embedded processors if you need to. But on the bad side, it's really hard to learn. There's no standard library for audio. There's lots of other libraries, but you kind of have to find the ones you like, put them together. They're all different. You have to fix all the interactions between libraries that you're going to use. You have terrible compile times. If you're going to support a lot of different platforms, you have to do different builds for all those platforms, which can become really complicated, and really your CI system ends up being your life, supporting all these different, and testing on many different platforms. And writing your GUI in C++, as we've just heard, is not great. It's possible. Again, you can do anything you want, but it's a lot of work. And it's not really designed for C++. And most of all, C++ is dangerous. And I've stood on stages many times and ranted on about how ridiculous it is that people who are not very good at coding are allowed to write C++ that goes into a DLL that gets loaded into the process space of a door along with all these other DLLs. And they all just get to rip around in the same bunch of memory, and like, it just shouldn't, you should need a license to do that sort of thing. So then you got C++ with all, and plus your library of choice. You pick one, you kind of go with a tooling framework. Again, fast, no brick walls in what you can do with them. These libraries are great, they've got great communities. Here's one. But again, you've got all the downsides of C++. It's hard, it's difficult, you make mistakes, even when you're good at it. The build times are bad, your turnaround times when you're playing with stuff is bad for GUIs, even if you use Juice. And it's dangerous. So what else can we do? Swift apparently is a good choice. Better than Juice, apparently. No offense taken. This is a lot easier. It's Mac only. It's you've got a great community again. It's good. It's easier than C++, a bit easier. But again, you've got it's faster than C++ to compile, but it's still a bit slow. And you're screwed if you want to use it on Windows or Linux or something. Faust. We've been hanging out with Faust guys for the last 2 days. Faust is a great. I don't know if you know it. It's a functional language for audio. It's fast. It's pretty good. It's got great library support. They've got all kinds of DSP algorithms in there. They've got great tutorials. It's supported on lots of platforms. You can try things out very quickly. It's a good prototyping language, so it's good for being inventive and cutting out the boilerplate and keeping you in your flow. It's safe. You can't crash the program, the computer with it. And is it easier to learn than C++? Not for me. I mean, I find it gibberish. You've either got a functional brain or you haven't, and I haven't. It's also tricky to debug, and there are use cases where you simply can't do something you might need to do. But people ship real products on it. It's great, but we looked at this in this sort of style. Then you can go to WebAssembly and JavaScript, which is again easy to learn. It's easy to learn the languages, but it's kind of hard to learn the tooling. There's you end up using Node.js and pulling in all libraries, and drives me mad. The developer tools are good, but there's lots of them, and they change every 5 minutes. You can, if you set things up, you can do live reloading of your audio code. You can get some really good turnaround times on that, and it's safe. You can't break anything with it. But the performance is not good. Even at its best, it's going to be much slower than C++. And if you're really pushing the boundaries with what you're trying to do, that can become a problem. And deploying it becomes tricky. I mean, it's great if you want to run in the browser, but if you want to run on an embedded device, you start to wonder about your choices. We'll go through a few others. Max MSP, you might know, great. Sort of whole low-code, dragging boxes together approach for building audio graphs works really, really well. So that's something for us to remember. But Max itself is pretty slow. They have the I forget what it's called, the compiled version, but most people just use the dynamic version, and it's also very, very hard to deploy anywhere. It's more for playing around, for prototyping. But again, great community, very safe. Oh, do you remember this one? This is pretty good. This is this idea that we came up with a while ago. Runs very fast, so you got your C++ performance. We thought it was easy to learn. We thought it was a good compromise between being safe and fast, and try to make it cover all the use cases you could come up with. Downside of Sol is it doesn't exist anymore, and there was never a clear plan for the GUI or how you would write glue code around the DSP. And obviously, one of the side effects of not existing anymore is that your library code's pretty limited, and the tools aren't there. But the concepts we still like. A lot of what made this good, we still think is good. I think this is the last quick mention, shout out to Elementary Audio, which is a really elegant idea. This is Nick Thompson's JavaScript, I don't know what to call it, library. It's not a library, it's a platform that he demoed at ADC. And this was really nice, all in browser, all the JavaScript, very nice to write simple functional-ish JavaScript, and you can write live reload and things. But again, things like this start to become very narrow in their use cases, and if you started to build a product on this, you're going to hit something it can't do and be stuck. So we did a big review of all this stuff and thought, what are we going to be? What are we going to do here? These are the kind of criteria that we need to look at. some of these are a showstopper. Others are nice to have. Don't bother trying to read all this. We kind of put good and bad ticks in boxes and try to think, okay, what can we do? Can we make something that ticks all the boxes there? For performance, we need to build something that's got C++ performance, and we decided, looking at all the options, we think a JIT engine is the way to go. We think when we've shown you can get C++ or better level performance out of a JIT using LLVM. And if you're running a browser, that is inherently a JIT engine, and we need to do WASM for that. But we also know that there's a use case where people are writing a product where they want to export some C++ and compile that in an old-fashioned or into some weird, for their own reasons, or for embedded devices, or for a very static project. So we need to support all these use cases. So whatever we build, it's going to have to do this. It's got to be easy to learn. And for us, and looking at the kind of target audience we want to hit, we think that means boring syntax, this C family, C++, C#, JavaScript, Java kind of syntax, where you write procedural code, and there's no surprises. But we also, a big takeaway from what's good out there is that graphs and being able to plug streams of audio together visually is a really powerful thing. So whatever we do needs to include that as one of its paradigms. So procedural code within graphs. And we need to be able to make this very accessible to make it easy to learn. So we need to make it easy to run online, get it in playgrounds, and we need to do good tools for code sharing and package management. Fast development, as in sort of fast turnaround. So if you have a JIT, this is great because then you get your live code reloading for the DSP side. But we also want fast UI reloading. So our choice for a GUI platform will be HTML and JavaScript as the basis of what we support. So that you can be hot reloading the DSP and also hot reloading your GUI with some JavaScript. Great tooling is essential for something to be successful. Not going to go into this in detail, but I think we've been around the block enough to know we're going to have to put a lot of effort into building some really great tools for our language, and we're going to dog food it. And dog fooding it is pretty good when you've got this huge parent company full of people who want to dog food your work. You've got to have great libraries. You've got to have some good content for people to use. So the way to do that is to get the hell on with it and write some good libraries. And also to make it easier for third parties to contribute libraries to the project. So this is all part of our game plan. And whatever we do, whatever we build, the language has to be able to offer very, very fine-grained control. So you don't end up in a situation where there's a bit of performance you just can't get right, or a little bit of just some manipulation you can't do or can't express. So we've got to really make it possible to get down to the bits and bytes level at least, and be able to not give people that showstopper just before they're about to release a new version. And for our glue code, we're going to go with JavaScript. So JavaScript and some other language are the kind of the very boring and down-to-earth choices we're going to make for the kind of the framework we're coming up with here. You get safety for free with these, so we're going to prefer our own language to be safe and JavaScript, which is safe. Obviously going to hit all the big deployment targets, the main big three OSs, and we'll want to support all the plugin formats. So again, very boring, obvious choices. A lot of work here. One of the tick boxes on our chart there is also industry adoption, like how widely something's used in the library. And that's usually the tricky part when you're doing something new. We happen to be in a really good spot here because we can dog food and actually get it adopted ourselves by our big, powerful friends. But very important, and part of what we're doing here is we're an independent company. So although we're part of Soundwide, we want to work with all Soundwide's competitors as well. And we have like a remit to be a very independent entity. So what our first goal is to make something that everybody in the industry is going to want. And we're hopefully going to set up a steering group from the wider audio community to try and make sure that we don't go off and do anything silly, and have a sort of more a committee approach to making sure that what we build is future-proof and a great long-term platform for everyone to use. Did I miss anything out there, Ches?
Well, let's work it out. No, that's good.
Yep. So, what's it called?
Hey, Jules, what's it called?
Yeah, what's it called? This is really annoying because what I wanted to do is come along here tonight and say, hey, and the great thing, we're going to do this thing, it's going to be called, but the lawyers have said we can't use that name. So, at the moment, we don't have a name.
Well, I was going to say we thought that we could use the first two initials of our names and put them together.
Yeah.
Jules and Ches. We thought
Yeah,
Juice or something like that. That might work.
Apparently, that wasn't gonna fly with the lawyers either. So, yeah. So the nice name that we have a code name, but it's rubbish, deliberately rubbish, so we don't keep it. Annoying, but hopefully we'll have a name soon, and then we'll come back and tell you what it's called. But the thing itself, I've kind of given a summary of like what it's going to do. When will it be released? When can you have a go? We have a working prototype. We're sort of working with it internally. We have stuff running on it. We've got tests. We've got a CI system. We've got we're kind of doing lots of internal testing on it. When will it be released publicly? Don't know yet. Not going to commit to anything right here and right now. But hopefully we'll have something out this year. Doesn't seem unreasonable. And I'm sorry to be a bit hand-wavy. That's all we can say at the moment. But I am willing to take questions. And
sorry, one of the important things is we've got budget to hire.
Oh yes, good point. Yes, because at the moment there's two of us, but we are hiring a few more people. So yeah, if you think that person could be you, get in touch. If you think you can write a compiler, come on. Yeah, come and give it a go. But yeah, anything else I've missed, or we could just have some questions.
No, I think questions is the right place
Let's
now.
do questions.
Oh yeah, that's a good idea.
There's another one.
Anybody?
Hi, thanks for the talk. Super interesting, really cool.
I'm sorry, it did feel like I was being very hand-waved. Oh, we're going to do... but we are doing all those things. We just haven't got a name yet.
Cool. Have you considered any support for like spatial audio formats and like integrating that into the libraries and that sort of thing?
It would be a library thing. I mean, what we're doing currently is agnostic about what channels go in and out. So we don't need to worry about that, I don't think. But it would be a library. And
so you're not even thinking about the library level at this point. It's just about.
It would be a library.
Yeah.
I don't think we'd need to do anything differently for our core platform.
Yeah.
It would just be people. Yeah, and that would be great to have actually. Yeah, we'll have to get Ben to write one for us at some point if he's not too busy.
Hey. Something that was quite cool about Soul was that it kind of abstracted the idea of buffers. You know, you didn't have to constantly write for loops over samples and channels. So will that be a feature of this with it having a kind of procedural interface?
Yes, there was a lot of good ideas that came up in there that we're going to reuse.
Hey. Is that like a juice machine that's about to be released? Hey, this is really exciting. And I just actually want to ask, follow up on the conversation that happened there. It's like, how are you planning to handle the UI layer?
Yeah, we're gonna go. That will be HTML and JavaScript, please, and whatever you want to do within that. So whether you want to use React or just write everything in plain old HTML or use some other framework that will exist next week is up to you. But we're gonna, so if you write a plugin with this and you kind of launch it in a browser, in a door, it'll be an embedded browser window, and you can do whatever you want in that. And the nice thing about that is we can also, we've also already got a prototype of like running that over a socket, so you can have your DSP on a different process, machine, whatever network, and it all just it works nicely.
Yeah, this sounds really, really cool. This sounds super interesting, but I suppose my question is, you're introducing a new framework, you're introducing perhaps a new language. How do you plan to make developers adopt this and train them up to know how to use it?
Cattle prods.
Okay.
Fair enough. Hopefully just by momentum.
What was the question?
The question was how do we expect to make anyone use this thing, basically.
Sorry, within the group or within the community as a whole?
Within the community as a whole.
Right. Well, the intention is that the group are going to be developing, for their own purposes, library DSP code, which will become available to the wider audience. So if this works out, where you should be is have an amazing collection of really good quality DSP components that are used for commercial products that you're aware of, and this will hopefully springboard the project and make it a fairly obvious go-to option.
Yeah, I mean, I can't speak on behalf of Soundwide or what they're going to build for the next 5 years, but they're funding us, and they're interested, and we're playing around with their engineers and seeing what we can do with this, and we expect it to be, it to be adopted, and hopefully it'll be good enough that you lot will just want to use it anyway. I mean, that's the idea. If we don't get that right, then we will give up and go and do something else.
Yeah, I think I've mentioned it before, but there's only so many times we should all be writing Butterworth filters or, whatever it is. And so if there's a really good quality implementation that just works, that is reliable, we should all be using it. I don't think the GPU shader guys think they need to reinvent the wheel every time. There's going to be libraries of standard components, and people say, I want this particular effect, here is a sensible implementation, I'll use it. So why is audio different?
Yeah, our joint strategies on that one are do it well, and Lord, we've been staring at this problem for years, and I think this is an itch we need to scratch. We need to get this. We know what the right platform looks like for what we all do, and we just need to finally make it. But that's our one strategy, is do it well, and the other strategy is brute force by having an industry gorilla behind us. And I think between those we might have a chance with this one. But yeah.
Hi, congrats on a project and really nice presentation. So I'm a lot into embedded devices and programming audio in this space, and has been surprised when I started my audio career about how we have to exactly reinvent the wheel every time we come on a new platform. But how much are you planning on like supporting specific platforms, or how much are you going to go into that?
Yeah, we're definitely going to have it on embedded. That's a big part of where we're going.
I think the focus initially will be on desktop platforms, mobile, so typical Intel and ARM devices, and we'll tackle those. Unfortunately, they won't be part of the initial target, but we are totally aware of the limitations, and we are thinking that way from the beginning.
Yeah.
I think Jules mentioned separating GUI components from the signal processing side. That's the kind of thing that makes us feel confident that we will be able to have a GUI, say, on a desktop controlling DSP on an appliance.
Who's next?
Sorry. So is it the idea with the kind of structure to be you put all your DSP in this kind of mysteriously named language, and then you'll use JavaScript or other things to interface with it. So if you've got MIDI input streams to whatever you're doing, then you handle that in JavaScript.
Yes, yeah. It's, for that example, I mean, your JavaScript wouldn't do much other than say, "Hello, I'm a plugin, and I have and please put your MIDI in here." And then it wouldn't be JavaScript actually serving the MIDI or doing much work. The non-real-time stuff, we want to lean on JavaScript. The real-time stuff, that's what this language is for. And JavaScript kind of holds it all together and starts it up and tears it down. And you'd have JavaScript that can generate this code on the fly and change it and have it jitted to do different jobs. So, but yeah, I mean MIDI, you'd get it on an input and you'd do some real-time code, twiddling the bits and bytes, send out some more MIDI, or hopefully not, because you'd use objects instead of MIDI events. But
Okay.
Timmer.
Beat me.
So you said JIT is a big part of what you're
We're
trying
into
to do.
JIT.
So what are you going to do on iOS where you're not allowed to JIT?
That's a good question. Thanks. I could rely on you for the hard one. We will be able to generate C++ as well. I mean, what we would do on Explore is running it on the GPU with Metal. So we'd be allowed to do that. It might not be as fast as on the CPU. It might not work very well. We might get latency issues, but it would be possible. Or as WebAssembly, take the performance hit, run that in your app. There are options, or we just go and, I mean, if only we had some friends at Apple. But yeah, maybe down the line we can persuade them, I don't know.
I think we know their secrets.
Oh yeah. I've got the photographs.
Okay, we have a number of questions from online. One question from Marvatronics is, has any of the language actually been designed? Type system, for example.
It's signed, did you say?
Designed.
Designed, yeah, it's running. We have it working.
Okay.
So yeah.
Sorry, we have something running. We can't share it. It's not
ready
at that. It's not at that stage.
But we're benchmarking on different platforms, and yeah, we work quickly.
Great. Matthew Hill asks, will the unnamed tool support third-party protection toolkits and suites?
I guess he's talking about like pace or something, I suppose. I haven't really thought about it yet. I mean, whatever you build, you could wrap in a signed wrapper, I suppose. There's no reason it couldn't. There's a whole discussion further down the line about whether we never need to obfuscate or encrypt the code when you're using a JIT.
Yeah, that's certainly an interesting question, and
I guess they were asking specifically about the type system.
The other question.
Yeah, the other question. Sorry, sorry. I'm getting mixed up. Yeah. It's late. It's nearly pub time.
Yeah, sorry to keep you.
Yeah.
Go on. Is that it?
Yeah, I had. Yeah. So, yeah, the other going back to the other question, they were asking specifically if you can reveal any details about the type system.
I've rewritten type systems so many times. It's a running joke, but yeah, we're on. Refactoring the type system can only happen so many times until you finally go, okay, I literally can't ever change this again. So
at the LLVM conference we were just at, somebody said it's MLIR makes rewriting your type system really easy, or something like that.
And I felt a little sag in my knees at that moment. But like, yeah, I never want to rewrite a type system again. But yeah, thanks for bringing up type system. Don't think that's a sore point. But we know our way around the type system these days.
Okay. And what about mobile platforms, Android, iOS?
Yeah, I mean, Android's easy. iOS, again, is easy as long as you don't want to deploy an app. But actually doing getting support on those platforms is easy.
I mean, I think the way that, I mean, if you sort of plan forward, the whole community starts using a JIT architecture like this, everyone moans at Apple and says, "Guys, what are you going to do about it?" A solution will be found. This is not impossible.
It might be, but then
it's not impossible.
If we can't do it, no one. They
right.
can.
Right. It can be done. It can be sorted out. But
yeah. I mean, hopefully it won't be a showstopper.
Does anybody use iOS for audio? Of course, yeah.
Another?
Yeah.
Oh, sorry. Well, just because on the topic, have you looked into WASI? WebAssembly?
Yeah, and well, it's not really relevant for what we're doing, to be honest. WASI is great if you're writing an actual app and you need all of the sort of POSIX level calls from WebAssembly. For us, we'd only be using WebAssembly to do the pure number crunching bit, so we don't need WASI. But if you're meaning in terms of iOS, then yeah, like WebAssembly on iOS is kind of, you're allowed to do that. So we might end up having to do that, although the performance will be pretty.
Yeah, I think we had a general feeling you get about 50% of the performance. I mean, iOS I don't know specifically, but across other platforms you see that sort of number. But there is a lot of, that community, things are moving quickly, and there's work on SIMD and things like that, which again will help. So it might be actually WebAssembly is perfectly good for a lot of use cases, but we don't know yet.
Yeah.
Any other questions? Everything I see online is a permutation of questions that have already been mostly answered.
And stuff you can't read out.
And stuff you can't.
So I don't know if it's been asked already yet. Is like the compiler and all the tooling going to be like open source and that sort of thing?
So I mean, we don't really have a plan for that at the moment.
Sure.
I'd like to, obviously. It makes more sense, and especially if you want adoption. I mean, it's obviously some of it will be open source. We might keep a few good bits back. I don't know, but yeah, I haven't got an answer at this point.
I think the way to think about it, the direction we're trying to go with the sort of a language steering group is to get the community behind and makes that aspect of the project open. That'll be available to everybody. But it might feel like it's just a language, but if you think about it, there's a lot of communication between the various components, or what the wire protocol is between the GUI and the service, and there's a lot of stuff to decide and to think through, and we're going to there's two brains here, and there's a lot of other people that know a lot about this stuff. So we collectively come together and we can come up with some really good standards that work well, that are future-proof and cover scenarios and situations that we haven't thought through. This is the power of the community as a whole. So I think we want to leverage that and get everyone behind a different way of thinking about how audio is, how audio applications are put together, and then we will have an implementation of that protocol and that language. As far as whether we open it or not, I don't know. It's a possibility, but we haven't decided anything really.
It seems likely, but yeah, we haven't got an answer.
Okay, we have another question about the JIT. Is the JIT only audio side? Isn't this going to introduce non-deterministic runtime on the live audio side?
No. It's gonna help. It's gonna be more deterministic. We've actually had some really good results from the JIT. I mean, we were dog fooding some machine learning matrix stuff.
Yeah, I've been looking at matrix type operations and comparing sort of eigen and other sort of C++ patterns that are commonly used, and yeah, we can match or exceed those algorithms in some situations, and this is the sort of stuff. It's not talking about determinism, but yeah, performance will not be a problem. Certainly, well-written library code will be tuned well. As far as determinism is concerned, that's just a massive subject, and we will absolutely aim to make the system deterministic, because the expectation, the whole power of these sorts of patterns is that you develop on one machine, and you gain confidence with your DSP, you deploy it, and it'll be running on platforms you haven't necessarily even got. and it's got to sound the same. I mean, there's absolutely no point if you do your development on your Mac and it sounds different or behaves differently on a Windows machine. That's not fun. We're talking about the sort of developer flow and trying to make people productive. You want to just sort of have gain confidence that you are not going to have to go around that loop of testing 14 versions of everything. Certainly if you're a sort of a small indie developer, using web tech for the GUI again gives you that sort of sense of independence. So this is the idea, is just to use the sorts of tooling that is most likely to allow indie developers to be able to produce high quality products across a lot of platforms.
Great. Okay, Mike.
Hi, yeah, you mentioned a couple of data flow programming languages as being, very good for kind of flow state programming. And you were alluding to Gen in Max, which gives you kind of a portal from a slightly lower level data flow environment into actual C++ code. And there are other examples like game engines, I think, that are very good at this. So how much are you planning on incorporating some data flow level in your work, and how much it might be a text-based level, and are these going to be equal citizens, or what's the flow
Good
between
question.
them?
I mean, I think it'll all be text-based, but we're designing it in a way that we can have graphical tools acting on the same data. So text that can be automatically edited by graphical tools is the dream. So you can either type it, or you can slap some blocks in and then go into the generated textual code and start tweaking it by hand. Is kind of the dream. We can do that. It's pretty straightforward. I mean, did I just say that out loud? I gotta stop saying things like that.
Yeah, I'd like to see a demo of that next week, Jules.
No, the principles behind it are quite. Yeah, someone else can write that bit.
Great. Please give a hand for Jules and Cesare. Great. Anything else you want to say?
No, we're done. We want to go to the pub now, please.
Okay. Yeah. So, on that note, I'll just say a few words. I want to thank Jules and Cesare, also Ricardo, Harriet, and Rachel for giving their fantastic talks and hosting. Please give it up for everybody who's been part of this meetup. Also, just wanted to give a big shout out to Sonics, Focusrite, and Juice for sponsoring our audio programmer meetups. Once again, they're every second Tuesday of the month. We have a community on Discord where we have over 7,500 developers from all around the world. Come join us. What else to say? Thanks to you for coming out. This is really exciting. I love seeing the mixture of people from all different backgrounds, all different experience levels. I think this is really exciting, and this has got me really excited for the future. And on that note, let's please don't be afraid to walk up to each other, introduce yourselves, even if it's somebody like Jules. I know that can be, I get intimidated when I walk up to Jules still. But please don't be afraid to mix and to network and to introduce yourselves. I think that's really exciting. And with that, let's all go have a drink. You can hang out here at the venue for a little bit, and then we normally go off to the pub across the street a little bit afterwards. So hope to see you there and meet you, and have a great evening.